Okay,
Yes,
so
sir.
we have to discuss practical electricity today. That is the last part of your current and electricity. Although the topics what we have studied till this point, those topics are enough for discussing all the areas of your series circuits, parallel circuits, yani DC circuits. But there are some questions which you will not be able to attempt, and those are actually the questions which are basically your fuse and circuit breakers and relays and use of those fuse, then potential dividers, LDRs and thermistors and etc etc. Okay, so when we will deal about these all, one more aspect what we have to discuss in this chapter, that is the use of electricity, dangers of electricity, and safety precautions about the wiring, household wiring, everything we have to discuss, right? So starting with the use of electricity. Use of electricity, everyone nowadays knows that we are using electricity, because when we are going to pay the bill, electric bill, then it is that much significant that we people now कि यार हाँ हम बिजली इस्तेमाल कर रहे हैं. So the problem in that all is actually that electrical energy is being obtained, or that is being used in heating, lighting, mechanical energy running over motors, etc etc. So when we are using the electricity in heating, like over electric irons, electric kettles, everything, so the energy is being converted, our energy is being consumed, right? These all are the appliances, in which we have to use the electric appliance, yani we have to use the electricity in the lighting of the bulb, etc etc. There are so many uh, appliances in which electricity is being used, so you are aware of all these. I have no need to get detailed of everything, how does it everything work. But in every appliance what I have shown to you here, uh, there is electricity used. So when electricity is used, definitely electric energy is used na, by straight away. So when electric energy is used, I can simply say that electric energy is a sort of energy which is obtained from the charge. For example, E is equals to Q times V is a basic formula for electricity, which we know that potential difference is equals to what? Work done divided by charge, and that work done is actually the energy stored. So it is E by Q. E by Q is equals to V. So you can simply say that E is equals to QV. So that is the basic formula you have to recall, and then along with that, your E will be VIT, because your Q, what is your Q? Q is your I into T. Okay. And when your Q is equals to I into T, you can simply say that E is equals to VIT. Walaikum salam. So that is basically the basic or fundamental concept by which you people are aware of calculating the electrical energy in the form of voltage and current, because most of the time we do not have this Q. What do we have then? We have V and I. What do we have? V and I, because in our appliances voltages are there and current is there. Along with that, I will consider another point, and that is that if you are using electrical energy, yani you are the electric energy consumer, you must be aware of power into time. This power means that what is the power consumption of your appliance, and how much time does it work. For example, if I will use an electric heater for more time, there would be more electric energy consumed and more bill will be there, right? Are you getting my point? So these are two equations which would be used. Rather, I will say that these are the three equations which you people have to recall by all means. And these all areas, yani these problem solving are the problem solving which are related to these equations. Yani in some of the questions, you will be given with voltages, current, and sorry, charge, and you can find the energy. So here you will use that electric energy is equals to Q times V formula. If current is given, volt are given, then you can simply use electric energy. Time is also given. So you can use VIT formula, etc., etc. So these all question. Yes. Any question?
Sorry, yes, sorry for interruption, but
No problem.
what if it gives you the current and the voltage, but it doesn't give you the time? I mean, is that possible?
Yeah,
Because
you
I've
will
seen
calculate power. Then energy will not be asked to you. You will be calculating power.
so, so for power, don't you need the
Yeah.
work done in time? For power, still you
No,
need
no, no, no,
time,
no.
right?
No, no. Electric power is equal to VI. In later on, I will show you in the slides that electrical power is equal to V into I. Okay.
Oh, okay.
So these all would be used. Then this is that electrical power. Electrical power was your neighbor actually. The power is the rate of doing work. What is electrical power? Electrical power is rate of doing work. So when we are going to do some work in terms of electricity, so we can simply say that electrical power is energy, yani energy divided by time. And electric energy, I have given you two equations. One is VIT divided by T, and T would be gone. So you will get P is equals to VI. That's it. Okay. The electrical power is equals to, yani from this equation we came to now that electrical power is equals to V times I, but mechanical power is equals to E by T. So any sort of work that can be done either mechanically or whatever, that is E by T. Okay, but general, that is the general formula of power, right? What is that? That is your general equation, a general formula for the power. Is this clear to you?
Yes, sir.
Okay. Now let's have some commonly used calculations involving are involved in the power. Power is usually used in milliwatt, watt, megawatt, kilowatt. So the common calculations are common units are watts and kilowatts in our daily life. For example, there are so many appliances which are operating or which have the power in watt, and there are so many which have the power of which have the power in kilowatt. So megawatt, kilowatt, you have to remember this. Kilowatt is basically 10 key power 3 watt, and megawatt has the 10 power 6 watt. Got it? And milliwatt is basically 10 power minus 3 watt. So I believe that that will be quite easy for you. Now in this slide, the all areas are the areas in which your power voltages are given. You can calculate either current is given, voltage are given, calculate power. Current is given, voltage are given, calculate power. Power, voltages, current is required, etc., etc. So this is just the practice of what? This is the practice of P is equals to VI. That's it. Okay. The main area over here is convert the time if it is required uh, in seconds. For example, the current in the toy car is 7 ampere. The voltage of the battery is this much. The power delivered to the motor, energy dissipated in this much time of operation. So power is equals to simply VI. So this is a trap. Got it?
Yes,
That's
sir.
why if you are asking just or if you are calculating power, this is a trap. But the question is calculate energy dissipation. So you know energy is equals to VIT. There all these three variables will be used. So just calculate the time into seconds and enjoy your answer. There are several more questions, right? Power of the bulb, power in energy dissipated in 10 minutes. So when power would be calculated asked to you, just check time is not given to you. When energy is asked, time is given to you. Okay.
Yes, sir.
Okay, so these type of questions are important for thermal physics as well, because in thermal physics we usually use electric heaters. Electric heaters are those heaters which are supposed to use voltage and current. When those heaters are using voltage and current, we simply say that these heaters are using a sort of voltage. 120 volt is the voltage and 4 ampere is the current, and it is used for 10 minutes, and it heats 200 gram of water. How much the temperature rise would take place? So this is actually, this question is from Q is equals to mc delta theta, isn't it? Here your Q is the energy which is coming from thermal energy. So you can simply say that this Q is the electrical energy. E stands for electrical energy, and I can simply write mc delta theta. So what is this Q? Q is equals to heat energy is equals to VIT, that is equals to mc delta theta. So everything is given to you. V is given, I is given, T is given, right? M is given, C is given, delta T can be calculated simply. Delta theta can be calculated. Is this all clear? So in those questions in which I was talking about the electrical, sorry, this thermal physics, there I have given you several formulas. One, Q is equals to, sorry, Q is equals to mc delta theta. The second one was uh, power into time is equals to mc delta theta. Third one was VIT is equals to mc delta theta. So that all depends that which equation is good for use. Okay, is it clear to all?
Yes, sir.
Sure.
Okay, now we are going to discuss about the bill calculation or energy calculations in kilowatt hour. So when we talk about kilowatt hour, this is really important technique, yani the really important thing for you. The for example, in this meter there is a reading that 25404.6 and 2542504. So there is a sort of chain in the reading na? So that chain in the reading is calculated, that 5425 minus 2540.6. So when they will be subtracted, you will be given the unit. So actually this is called kilowatt hour. What is that? Energy, electrical energy consumed. Here is the important thing, that define the kilowatt hour and calculate the cost of electric appliance use where the energy is in measured in kilowatt hour. So one important thing for you all, that is when you are going to calculate the energy will be calculated in kilowatt. Yani electrical energy will be calculated in kilowatt hour. So actually kilowatt hour is 1 unit of electric energy used.
So,
Okay.
sir, when we're asked to calculate the energy transferred, do we calculate it in kilowatt hour?
Yes.
Like,
If it is, there are two options for you. If the answers are given in kilowatt hour, I will yani, attempt some of the questions for you. If the answers are given in kilowatt hour, yani unit is given in kilowatt hour, then you have to convert it into kilowatt hour. If the unit is into joules, you have to convert it into joules. Simple. ठीक है. So electric consumption is made into kilowatt hour. So electricity bill is used or calculated for 1 month. What is the basic technique of kilowatt hour? If you know, kilowatt hour is the amount of electric energy. This is not power. Only kilowatt is just trapping the students. Okay, yeah, this is energy. This is kilowatt. Sorry, this is power. No, it is not like that. It is simple that uh, it is simple कि यार electrical energy used in a specific time, that is kilowatt hour. ठीक है. Electric energy है, बस simple आपने याद रखना है. What is that? That is electrical energy. Now energy released, yani what is basic technique, and this technique will be used all the time. What will you use? You will have energy calculations in power into time, definitely. Okay, and if energy is 1 kilowatt hour, then power should be in kilowatts and time should be in hours. ठीक है जी. So in 1 kilowatt, how many watts are there? 1000 watts are there. Okay, and in 1 hour, how many seconds are there? 3600 seconds. It means this is 36000000 joules, because watt into second is joule. So you can simply say that 1 kilowatt hour is equals to 3.6 megajoule. It is simple and realistic that you have to convert that in with convert that by multiplying 3.6 megajoule. Yani, for example, if your bill is 540 units, right? What is your bill? 540 units. So it means this is 540 kWh. How much is that? 540 kilowatt hour. So Kilowatt hour is 540. So in megajoule or in joule, what will be the value? In 540 into 3.6 into 10 ki power 6 joule. So you had consumed this much electrical energy at your home if the bill, जो electricity bill hai, if that is 540 units. Is it? Are you getting my point?
Um. Okay, I get it, but
Okay. The area to be discussed is, or area to handle is, that here you need, what is the requirement? What do you need? You need power of appliance in watt, power of appliance, whatever the power of appliance is, that is in watt. Okay. And time of utilization. Okay. It depends whether what is basically time in hour, second, minute, whatever that is, right? So if it is not in hours, you have to convert, or if it is in hour, then it is fine. So electrical energy in kilowatt hour, that is equals to power into watt into time into hours divided by 1000. Why did I make 1000? Because power is in watt
what?
now, so I have divided this by 1000, so it is now kilowatt hour. So let's say you have so many examples ahead. मैं उनमें से एक दो उठा लेता हूँ. Suppose a 15 kilowatt heater is switched on for 4 hours. How much electrical energy does it transfer to the room in kilowatt hour? Are you getting question number one? This is power into
Um.
kilowatt hour. So no need to divide by 1000. And time is in hour. So electrical energy is equal to simple power into time. So what is power? Power is 1.5. Actually, it is kilowatt hour, na? Kilowatt hour. So I will not use 10 ki power 3 here. And time is 4 hours. So it will be 6 kilowatt hour. Is it clear to all?
Yes, sir.
Okay. Then what is the cost of each kilowatt hour? Cost 15 cents. What will be the total cost if you are using 6 units of electricity? One unit cost is how much? One unit is 15 cents. So total cost will be, for
90
total
cents
cost, not for month. Yes, 90 cents. But for month, कितना हो जाएगा?
per month.
90 times
19
30.
to
So it
30.
would become 2700 cents. तो ये आपके पास
Nito,
काफी सारे
isn't
पैसे
it
बनते हैं.
for a month? I mean,
नहीं. No, no, no.
the one point, I mean, the energy transfer, isn't it the month thingy? Wait.
No, it is for 4 hours.
Oh,
Till this point, it's for 4 hours, because it it works 4 hours. If it is written, it works 4 hours daily. Then you will use 4 into 30. Okay,
okay.
got it?
So, but then the answer will be 90 for the B part, right? Currently.
Answer will be 90 cents only. Oh, sorry, six. कितना होगा? हाँ, 90 cents. Your
Okay.
answer will be till 90 cents. Okay. Next पे आइए. Four A 4 kilowatt appliance converts electrical energy into, how much energy does it converts in 10 minutes? If the electricity is itne, right, how much does it cost to run the appliance for 10 minutes? If the potential difference across the appliance is this, determine the current in it. So that is an extended version of that. So first of all, what will we do? You have time,
Convert the time to hours, I think.
yeah, and this is in kilowatt. So that is basically, you can say that power energy is equals to 4 into 10 divided by 60, because I have to convert that into hours. Is it clear to you?
Yes, sir.
Minutes are to be converted into hours. No?
Hmm. So it's gonna be no wait.
हाँ नहीं समझ आया.
Wait. It's gonna be then two by three 0.6666 something.
यस.
That is what
तो
I get.
इसको सॉल्व करिए. तो 2.40 डिवाइड बाय 60, तो ये कितना हो जाएगा?
Nee, the
0
thing
पॉइंट
that
समथिंग.
you wrote, it's gonna be 0.666.
कैलकुलेटर बाबा, कैलकुलेटर. हाउ मेनी स्टूडेंट्स हैव कैलकुलेटर प्लीज? जल्दी से 40 डिवाइड बाय 60 कर लीजिए. 2/3. 2/3 इज बेसिकली 0.67. ठीक है.
Yeah.
ओके, गॉट
So,
इट.
but like, how many significant figures do we have to round in here?
Not more than 2, because the answers have sorry, data has 2 significance.
Okay.
4 किलोवाट पे भी जा सकती हो, 0.7 भी कर सकती हो, but 0.67 is fine, no issue at all. Okay.
Okay.
Okay, then we have we can make it a bit complicated question. For example, if we have several electrical appliances, let's say I have 4 fans, 2 heaters, okay, 1 refrigerator, okay. Every fan is of 120 watt power supply, I mean power rating. The heaters are of, let's say, 3000 watt heaters. Refrigerator is, suppose, 5000 watt. Okay. And heat fan is running for let's say ये हीटर की बजाय ना आप इसको इलेक्ट्रिक हीटर कर ले, कैटल कर ले. They are working for 6 hours daily. That is working 2 hours daily, and the refrigerator works 18 hours daily. What will be the total electricity consumed in kilowatt hour? So what will you do? You will find its powers of consumption, है ना? 120 into 6. So you will say 120 into 6 divided by 1000, because that is in hour, plus 3000 into 2 divided by 1000,
But then the
plus
fans are more. To
हाँ,
multiply by 4 नहीं
इसको
करेंगे?
मल्टीप्लाई बाय 4 करना है, मल्टीप्लाई बाय 4 करेंगे, राइट. And then 5000 into 18 divided by 1000. So just tell me the complete answer of
Also,
that one,
sir,
please.
heaters को multiply by 2.
हीटर्स 2 है ना,
Yes.
तो इसको भी मल्टीप्लाई बाय 2 करो. यस.
Wait, let me calculate just a second. It's gonna be 1002 plus 2 into 3000 into 2 plus 5 plus 5000 to 18 by 1000. It's gonna be 104.88.
104 point something, right?
Yes.
Kilowatt hour. So these much units you have consumed. ठीक है.
Yes. Got it.
यानी these much units you consume daily. These are the daily consumption. So for 30 days, what will you do? You will multiply 104 into 30. You will get some big number, and then you will apply the electricity cost. Actually, in our daily life, whatever the electricity our bill we calculate, they are not on these much units. That is a complete composite calculations from 1 to 200 units, from 201 to 4, yeah, 400 units, something like this.
So they have a range, you mean?
Yes, but you will not be asked about that. You will be just directly asked what will be the calculation. So is it clear to all? Khadija, Mariam, Zainab, Ariba?
Yes, sir.
Okay, go to the dangers of electricity. अब आपके पास जो dangers of electricity है ना, there are so many, because we are यानी more vulnerable to the electricity or electric shocks or electric hazard in our daily life. So there are so many hazards, and what are the possible consequences? There are hazards of worn cables, damaged plugs, then water around the sockets, then pushing the metal objects into the sockets, which we usually do with the nails when we have to be kids. And in our childhood, everyone performs this experiment, which is actually free of cost. No physics lab is required for that. Then overloading of the socket, we usually do this in the old age, yani when we have grown up and we say, yaar abhi kaun jaye दूसरी socket में, लेकिन इसी में लगा लेते हैं, right? Then long coiled cables of an electric heater, this is observed, but this is rare. Right? What are the consequences of, for these two consequences of damaged plugs and the cables? They can uh, cause short circuiting, and because wires are exposed, so when wires would be exposed, definitely there would be a damage of or threat of electric shock. Then water conducts electricity, so again that is called the damping effect. So basically there can be a sort of electric hazard or electric shock. Then metal, when you are pushing a metal object into it, definitely it conducts the electricity, and that conduction of electricity makes the electric shock. And overloading of the socket draws a lot of current from the main extension. देखो, I'm talking about the extension, I will show you all of this, and that becomes heat up. And when it becomes heated up, the metals are sorry, the insulation is damaged, so the fire can be caught.
Sir,
In the
can you give an
same way,
example of? Okay, never mind.
so the coiled cables in the electric heater has another problem, because when you are going to make it coiled, basically you are going to increase the resistance, so there would be more current, yani more opposition to the flow of current, so there would be more heat, and that creates yani more heat, and there is a damage of catching fire in the cables. So these are some available areas. Here every yani hazard is I tried कि every hazard को हम लोग show कर सकें आपके लिए, ठीक है?
Sir, I
Insulation,
have
damage
a
insulation.
question
Yes, yes,
from the
please.
table.
Carry on.
Sir, the last thingy of the coiled cable, I mean, it increases the resistance so the current is less, but then how does it cause the heating effect? Isn't the heating effect caused when the current is more? I mean, current causes the heating effect, right?
Yes, you're right, but the problem is when we are making the coil, actually you will not be able to understand this concept at this level. That's why I just skipped it. The problem is the coil making causes the wire to be acting just like a solenoid. Okay?
Okay.
In the electromagnetism, you will come to now across you will come to know about that. So in these solenoids, electromagnetic induction takes place, and there is another sort of current, which is induced current, which takes place in the coils. So that is why it is avoided, yani it is advised that don't make the coil of the heating coil of that wire. Okay?
Okay, and I have one more question.
Yes.
Sir, could you give an example of pushing the metal into the socket? I mean,
Yes.
conflict.
Should I switch on my camera also?
Um, I mean, if that's possible, then fine.
यस, तुम चाह रही होगी ना अयाज फिजिक्स ना पढ़ाई इसके बाद, पुत्र?
नहीं
मेटल सॉकेट में डालने का मतलब इलेक्ट्रिक शॉक है, समझ आई? कभी नहीं किया तूने जिंदगी में?
नहीं पता नहीं. That is why I'm asking you to give example.
करके देख लेना ना, ये तो बहुत आसान सा प्रैक्टिकल है।
Mariam,
जैनब इसको
don't try.
समझाओ। जो चीजें जितनी समझाई जाए बस उनको उतना ही रखा करो पुत्र, मुझे पता है किस चीज को कितना डिटेल में लेके जाना है, ठीक है? ये जो
Okay.
कील, देखो मेरी बात सुनो, इट इज सो डेंजरस। बचपन में सब लोग एक काम करके देख रहे होते हैं, स्पेशली जिनके घर में कोई ये इस तरह की कोई कंडक्टिंग चीजें, वायर, वो केबल्स वगैरह, सॉरी नेल्स वगैरह पड़ी होती हैं, और screw drivers or anything wire, we used to plug in that in the in the socket, right? So we try it, everyone, यानी पता नहीं तुमने नहीं ट्राई किया, तुम तो अम्मा ने तुम्हें बहुत ही प्रोटेक्टेड रखा हुआ है, इसका मतलब है। जैसे मैं तो बच्चों को पकड़ के एक दफा करंट लगा के दिखाता हूँ कि पुत्र यहाँ से करंट आता है, ताकि उनको
सर मेरे
महसूस
अब्बू
हो कि
भी
दूसरी
ऐसे
दफा नहीं।
करते
सही करते हैं ना, ताकि एक दफा फील हो जाए, आइंदा आप लोग हमारी अब्सेंस में ना ना वहां पंगा करो।
So you mean like an example could be pushing an iron nail into the socket?
Yes sir, perfectly. Can you do
I
it?
haven't. नहीं मैंने कभी किया तो नहीं है, but like not a bad idea.
हाँ
मरियम
ओके।
करना भी मत प्लीज।
ये या घर वालों से तंग है या मुझसे तंग है, बस ये एक मुझे ऐसी लग रहा है। ठीक है,
Okay.
दोनों साइड से मेरी तरफ से कोई प्रॉब्लम नहीं है, मैंने तुम्हें माफ किया। घर वालों से अगर तंग हो तो फिर पहले मतलब वो लिख लेना कि इट वाज नॉट इंस्ट्रक्टेड बाय फिजिक्स टीचर, neither फ्रॉम माय पेरेंट्स। ठीक है, आई एम डूइंग बाय माय ओन सेल्फ, सेल्फ एक्सपेरिमेंटेशन।
Okay, well.
ओके, अब आगे चलते हैं। yes, this is one of the main reason of अच्छा यहाँ पे आप लोगों को एक और चीज बता दूं, this is this is usually observed in electric irons, ठीक है, mostly because of the heating effect and twisting, and this is not that much dangerous if it would be, yani insulation is removed in such a way that
Sure, but isn't the wire protected inside?
इसके अंदर threads होते हैं ना,
नहीं
if the
क्योंकि
threads
threads
are
के
open here, then this wire is much dangerous than this situation. मैं यहाँ पे दिखाता हूँ, आई होप सो कि कहीं मेरे पास शायद उसमें पड़ा होगा वायर।
no, I mean like if threads are open, you have another like a covering on the wire. So how is like isn't it like kind of more protected? So like even if the cloth thingy is removed, the cotton thingy, you still have inside there like I think plastic wrap
yes,
around it or something like that. So like, is it still dangerous?
मैं दिखाता हूँ तुम्हें, just a second. Damaged insulation of wires. पुत्र आज तुम्हें ना वायर दिखाते हैं अंदर से एक्चुअली वायर कैसी होती है। एक्चुअली वायर कभी आप लोगों ने वायर नहीं देखी कभी काट के?
देखिए, but like I've just seen that golden thingy in it.
हाँ, गोल्डन कॉपर होता है उसमें, तो दैट इज एक्चुअली द करंट कैरिंग वायर, जो आप कोशिश करें कि डोंट टच इट।
So, but
ठीक है,
normally it's covered with the plastic
हाँ मैं
thingy
दिखाता
around
हूँ।
it.
यस, वो जो प्लास्टिक थिंगी है ना, वो तुम्हारी इंसुलेशन होती है। ठीक है, हाँ
Okay.
ये इंसुलेशन है, एंड इनसाइड द इंसुलेशन देयर इज अ sort of wire which is current carrying wire। ठीक है, अब आप देख लीजिए, ये दिस हैपेंस, अगर ये जो इंसुलेशन के अंदर वाली जो चीज है ना, इफ दे वुड टच ईच अदर, then this would happen. Insulation prevents the mean contact of those metals which are basically the current carrying wires. Actually current carrying wires are there, so these are the, yani the wires are colored by the insulation। अब मैं आपको एक और भी चीज दिखा, there are so many examples तुमने देखी होंगी लाइफ में, मैं तुम्हें यहाँ दिखा देता हूँ। Yes, did you see that?
Yes.
This is that damaged insulation, मतलब पता चलता है ना कि डैमेज इंसुलेशन।
Oh, so if the two golden thingies they touch each other,
Yes,
then it's like a
these are the
spark.
copper wires. Yes. Is it clear?
Okay, yes, I get it.
Actually, so never touch that gold, which is actually not a gold. It is copper. Is it clear to all?
Yes, sir.
So actually,
Yes.
this is that. Haji, yes, yes, yes. Any question?
No, sir.
Okay, very good. It means you people now the threats of electricity, है ना?
सर फर्स्ट हैंड सीखी है तो आना तो चाहिए.
ये बड़ा जरूरी है सीखना. इसके बगैर तुम लोग ना देखो. Why I used to talk about this in detail, because electricity is that type of energy or that type of damage, danger or threat which is available all the times in our homes. और मजे की बात ये कि we basically purchase it from market. आपको पता है these instant geysers, how dangerous they are if they would not be properly uh, quality tested or properly insulated. Then there are so many areas. Yeah, this is that wire. मैं जो बात कर रहा था आपसे, this is the conducting material. This is conductor of the wire. These are the insulation wires, right? So copper color would be same na. So we use insulation over copper to just make the colors, and those colors are basically used in identification. Okay, so damage insulation के बारे में मेरा आप लोगों को काफी चीजें क्लियर होगी होंगी. So overheating of the cable means when you have a lot of current flowing through the wires, due to that, due to I square R into T, what happens? There is a thermal energy produced in the wires. So that thermal energy is basically nothing. I did not write any difficult thing. That is I square R is your power, and power into time, that is power, and that is time. So power into time is your energy. So if you have more current in the wires, then what will happen? There will be more electrical energy and more heating effect will be there. And when there will be more heating effect, there will be a time when those wires would be melt. And when the wires will melt, yani those insulation will melt, they will catch fire because oxygen is available. If the temperature will rise to a certain level where the fire can be there, so that causes the fire. Okay, तो आपने ये देखना है.
So,
It don't make a damping. Yani this is that what do we do in our daily life. So this is a tiny extension, and over that extension we have lot of appliances. So every appliance is draining the current. So when they are draining the current, all the load is where is all the load? All is the load on this extension cable. Okay, so this would be heated up. Is it clear?
yes, sir. But then, if
Okay.
it's if there's a chance of catching fire, why don't they create a vacuum between the insulation
Right?
material and the metal?
हाँ, पाकिस्तान में महंगी होती हैं पुत्र चीजें ये सारी.
मतलब होती है.
होती हैं, yes, of course.
Uh, yeah, but this is
Fireproof
protection.
materials. Life is not that much worthy in most of the countries than that of money. इसलिए जो ठेकेदार होता है ना हमारे यहाँ, उसमें मार्जिन थोड़ा ज्यादा कमाना होता है. सो इंसुलेशन भी बहुत हल्की फुल्की यूज की जाती है, जस्ट कवरिंग होती है ऊपर. ठीक है. So there are fireproof insulations, but they are not commonly used commercially. कहीं नहीं यूज होती. आप में से किसी के घर में fireproof insulation यूज नहीं हुई हुई. ठीक है. So they are the military installations or military equipment or appliances where they use it, are those type of devices which are sent to the space. ठीक है. तो
नहीं
हमने
तो
क्योंकि
जब
जमीन पे रहना है. बोले.
No, because the when you can create a vacuum between like a double glazed window or something, then or
Mhm.
even between the walls, then why can't you create it between the two pieces of wire? And I mean the insulation
Ah,
material and the wire.
there is insulation material in the wire, but vacuum is not being created.
So, मतलब जब windows और walls में हो सकता है तो wire में क्यों नहीं हो सकता?
जो काट के वायर को लगाएगा तो उसका वैक्यूम तो निकल जाएगा ना उधर।
Ah, yeah, that is true.
मुझे बता कि जब तुमने वायर काट के ही लगानी है तो हाउ विल यू प्रोटेक्ट द वैक्यूम? गुड। ओके ओके। डैम्प कंडीशंस का मतलब ये होता है कि when the skin is wet or the wires are placed in the moist environment, then what happens? Sometimes did you observe that we have some sort of moisturized environment or atmosphere, then over laptops or over PCs, they they just provide you a little electric shock. So electric shocks have different ranges. For example, if the current is 1 milliampere threshold, that will not give you any pain. Below this point it is just 1 milliampere. So for example, 1 milliampere is the current which is available in the mobile chargers, right? That is that is very small current. Then 5 milliampere is the current which a frightening but harmless shock जो हमें लगता है ना usually बचपन से लेकर आज तक, that is the threatening, sorry, frightening means we face के ओए करंट लग गया यार, that is frightening, but that is not harmful, right? Then 10 to 20 milliampere current, that basically the uncontrolled muscular contraction cause कर सकता है, loss of muscular control cause कर सकता है। करंट कितना है आपका? मिली एम्पियर है बच्चों, just mind it. And if there is a 50 milliampere current, the pain and exhaustion, breathing effect can be caused. And then 100 to 300 milliampere current जो है uncoordinated contraction of the heart leading to death. So आदमी को मारने के लिए सिर्फ 300 milliampere current enough है. So believe me, it can be very easily available in most of the appliances. ठीक है? For example, our
Hmm.
body, यहाँ पे आपने याद रखना, this is the most important thing for you, especially for you people. The size of, आप लोग जब hair dryer use करते हो ना, that's why I'm saying that for you people, that is very dangerous, a hair dryer जो होता है, because there is almost 2000 watt heater inside it and almost 10 ampere current is available in that one. 220 volts available होते हैं. The size of the current which flows depends upon the voltage and the electrical resistance of our body, right? So most resistance of the human body lies in the skin. Dry skin होती है. So dry skin has the resistance of 100,000 ohm or more. So if you are having or if we touch 220 volts power supply, then I is equals to V by R. So 100,000, तो चेक करो कितना करंट निकलेगा बॉडी से? 0.22
zero
मिली
point
एम्पेयर।
zero
हाँ वही है,
zero two two ampere.
0.22 मिली एम्पेयर। ठीक है, तो
Hmm.
दिस इज वेरी स्मॉल करंट, but if the skin is wet, the resistance decreases to few hundreds ohms. I just read in some of the books that it reaches to 100 ohm, yani 1000 times kam ho jati hai. So when you have 220 volts and 100 ohm resistance only in the body, then current would become how much?
Two
0.22 ampere, which is basically equal to how much milliampere? Yes, 20, कितना हो जाएगा ये? इसको
two
मल्टीप्लाई
point
करो
two नहीं
1000 से।
होगा? नहीं.
2.2 होगा इधर से, हाँ हाँ 2.2 एम्पेयर, यस यू आर राइट, 2.2 एम्पेयर इज विल बी द करंट, एंड 2.2 एम्पेयर मींस 2200 मिली एम्पेयर। हम 300 मिली एम्पेयर नहीं बर्दाश्त कर सकते, सो इट वुड बी 2000। 2.2 एम्पेयर कितना होता है? 1000, वन एम्पेयर इज 1 मिली एम्पेयर, सॉरी 1 एम्पेयर इज 1000 मिली एम्पेयर, 2.2 एम्पेयर कितना हो गया? 2002, isn't it?
Yes.
सो दैट इज वेरी डेंजरस. सो इसलिए आप लोगों ने अवॉइड करना है इसको. देन सेफ यूज ऑफ इलेक्ट्रिसिटी इन अवर होम्स. When we are talking about the electricity in our homes, we must now the household electric appliances formation. That is, this is the main circuitry which is basically overlaid in all of our homes. आप लोगों ने देखा होगा. This is, you can call it, the electricity, इलेक्ट्रिसिटी क्या बोलते हैं उसको, इलेक्ट्रिसिटी डिजाइन. ठीक है. Our map, electricity map in the household appliances. So this is the main fuse, our main circuit breaker. Our main cable is coming from outside, from Babda. And then neutral wire, there are three wires. Let me tell you about the wires first, and then we will talk about their uses.
सर
Just
कितना रहता है?
बस मैं भेजता हूँ तुम्हें. Yes, there are three type of main wires. ठीक है. Yes, there are three types of main wires. These are three wires जिसमें आप लोगों को ये देखना है कि one is earthing wire. यहाँ, yes, ये यहाँ पे. The live wire or live pin that carries 200 to 300 volts basically. ठीक है. This is your live wire. Live. Then this blue or black. Actually, the color of that live is red or brown, and its color is blue or black also, and that is green and yellow. So this is important to know that red or brown color wires carries very high voltages. So if we will be able to, or if we can any ever touch them, and the other part of the body is attached with the ground or any other wire, then it would be dangerous for us. So this is the, again, this is the live wire, this is the neutral wire, and this is basically the earthing wire, that one. I will talk about these all in detail. Just मुझे ऊपर जाने दें वापस. Live wire is, here is your live wire. Yes. Yeah. Here is your live wire. ये देखो. This one is your live wire. Live wire is controlled by a fuse. In the fuse is always used in the live wire, right? And this way. So here your electric meter is there, and two wires are coming into the meter, two wires are going out of the meter, and then again live wire is here. So this is your live wire, right? And live and neutral both are cut off over here. This is the main switch. When you will apply the main switch में आप क्या करोगे? Everything would be cut off, either live, either wire, either neutral. So live would be, when you will close this switch, what will happen? Live would be flowing in this wire, and there are several rooms in our homes. They go, this 5 ampere fuse is leading, or that is controlling lamp number 1, lamp number 2, lamp number 3. Then this 5 ampere 15 ampere fuse is controlling the water heater. Then this 30 ampere fuse is controlling all room containing your uh, power circuits. These all are the power circuits, right? Because in these power circuits we really apply the main, you know, बिग पावर अप्लायंसेस, लाइट, राइट, जिसकी पावर ज्यादा होती है. आपके पास कुकर्स हो गए, आपके पास ओवन्स हो गए, वगैरह वगैरह वगैरह. सो देयर इज एन अर्थिंग वायर आल्सो. चेक दिस वन आउट. द third earthing wire is basically, here it is touched here in the outer circuit. Did you see the earthing is there? So let me give you the color of the earthing. That is usually green color, or green and red. So earthing is here, earthing is here, earthing is here. So all these wires are connected to the ground. Okay. Finally, and finally, earthing is connected to the ground. So every wire, live wire is bringing the voltages to the appliance, and neutral wire brings the voltages back to the power supply. ये आप लोगों ने यहाँ पे देखना है. और यहाँ पे देखो, अर्थिंग और अर्थ लीकेज सर्किट ब्रेकर. आपके पास ये बेसिकली सर्किट ब्रेकर की एग्जांपल है. नो नीड टू गेट इन डिटेल ऑफ दैट कि व्हाट इज द मेन फंक्शन ऑफ द सर्किट, यानी हाउ डज इट वर्क. बट सिंपली यू कैन अंडरस्टैंड दैट सर्किट ब्रेकर्स आर automatically, they automatically control the power supply, yani they break out जब आपके पास करंट एक्सीड करता है ना देयर वैल्यू, फॉर एग्जांपल दिस सर्किट ब्रेकर इज 20 एम्पियर, so when the current will exceed by this 20 ampere, this circuit breaker will be down and it will not allow the current to pass through. In the same way, this is a relay switch, and in that relay switch we will talk about that in electromagnetism in detail. Circuit breaker relay, so I will discuss that in detail in electromagnetism, otherwise it would not be, you will not be able to understand it properly. It is just a simple device. Let's talk about the
Sir,
fuse. Yes.
next class, eh?
ठीक है, तुम जाओ, ये रिकॉर्डिंग सुन लेना इसके बाद।
Okay, sir. Thank you so
ठीक है,
much.
वेलकम वेलकम।
The
Okay, so
office.
fuse is basically, fuse have a proper rating on it. So every fuse is replaced with the proper value. If you do not have that fuse, don't change it. Fuse के अंदर होता क्या है? This is the metal casing on two sides, and there is a thin wire in between. There is a thin wire in between. Then what will happen in the case of huge current flowing through? This wire will melt, and this fuse will cut off the power supply. ठीक है, लेकिन ये फ्यूज काम किस पे करता है? इट वर्क्स ऑन द प्रिंसिपल ऑफ हीटिंग इफेक्ट. Wire heat up hoti hai, and in between the glass sheet there are two types of fuse. This is the ceramic fuse, and this is the metal, yani this is the glass coated fuse. So glass coated fuse are really available in the market. We have these, not ceramic ones. So every fuse has its power supply, yani its current rating. Ye dekho, this is very important. These fuses are available in your cars. Remember one thing. कभी देखें किसी ने? There is a fuse box in your car, and every function of your car is controlled by these fuses. तो इसकी कलर मैचिंग भी आपको पता होना चाहिए. दिस इज द पर्पल इज द लीस्ट 3 एम्पेयर, देन 5 एम्पेयर, देन 7.5, देन 10 एम्पेयर, देन aqua color is 15 एम्पेयर, देन येलो is 20 एम्पेयर. सबसे जो बिग कलर होता है, that is green. Green is basically 30 ampere fuse. So they must be replaced properly according to the color scheme. They have the wires inside this one, and that makes a contact. Either it breaks or makes, but that is basically controlling them. तो फ्यूज का आपने देखना है. फ्यूज इज यूजली कैलकुलेशन ऑफ द फ्यूज मैं यहाँ पे आपको बता देता हूँ. आई थिंक this would not be here, but here you have to learn about the calculation of the fuse, that selection of fuse basically, right? What I'm talking about, the selection of fuse. Fuse is selected by calculation of current. I is equals to P by V, where P is power rating of your appliance, power of appliance, and V is operating voltages. Operating voltages. For example, when you will calculate this current, you will get the current, you will yani normal current in that. But fuse will current of the fuse will be little bit greater than the current calculated. Calculated current से आप fuse थोड़ा सा बड़ी वैल्यू का रखोगे. सही है, बात समझ आ रही है? For example, in your there is a electric kettle. Its power is 3000 watt, and it is operated at 220 voltages. So what will be the current flowing in that one? I is equals to P by V. So it is 3000 divided by 220. Yes, अरीबा या जैनब, कैलकुलेटर अभी आप लोगों के पास है, because Mariam is not in the class. So what would be the value?
This degree of sex okay, that. Sir, the answer is 13.6. So you could say like 14.
Yeah, 14 ampere. And fuse you will select that is that is fuse, that is your almost 15 ampere. Okay, fuse will be selected if it is available in the market. 20 ampere will chal jata hai. Okay, is it clear?
Could you do this one more time, sir?
Yeah, I'm saying that the calculation you got is 14 ampere. 14 ampere is
Right.
basically the current in the appliance. Current in appliance. So appliance would have this current, then fuse will be used a little mean of a little greater value. Current in the fuse should be greater than current you have calculated. That's it. So that is why if you are going to select a fuse, either select 15 ampere fuse or 20 ampere fuse. That's it. ठीक है? Is it clear to
Okay,
all?
sir.
एक मिनट, ये नूर ने मैसेज किया था ग्रुप पे. That is why I am saying
Who,
that.
sir?
Why is that? Okay, ये बात समझ आ गई सबको? There are some, the operating voltages are 230. The power ratings are given to you, so you can select the fuse for every appliance. Yani, for example, if this is 900 watt appliance iron, electric iron, so how much current will it carry? Calculated current कितना हो जाएगा इसका? I is equals to P by V. So power is 900 watt and it is 230 volts. Calculations करना जरा. Yes, yes, hurry up, hurry up. Are you people there in the class?
Yeah, sir, sorry. I had grabbed my
जल्दी
calculator
करो,
again.
टाइम नहीं है.
3.91.
3.91. Yani 3.91 is the current flowing through that. That is calculated current. But you will select a fuse of almost 5 ampere. That would be suitable. Okay?
But why is that, sir?
Because when we will use a fuse of little greater value, in appliance current can fluctuate a little bit. For example, your motor is working here and its operating voltage or operating current is 5 ampere, sorry, 3 ampere. So sometimes current can be more than 3 ampere, but 5 ampere is that current which has its limit. If I will allow more current than 5 ampere, then it would be damaged. Yani that is 5 ampere current is actually the controlling current. I would not allow the current to overflow than 5 amperes. So maximum current which can be held by this motor is 5 ampere. ठीक है? So
So there should
mostly
always
the
be a little bit
appliances,
more.
yes, yes, simple. You have to remember one thing only, that fuse has always a little greater rating. ठीक है?
Okay, got it.
Never use the fuse smaller than the calculated current. Got it?
Understood. Got it.
Okay, then the final task for this one, this is earthing actually, is that type of mechanism in which what do? We connect the body of the appliance to the grounding wire or earthing wire. Due to that, if someone touch the body, it would be safe. For example, check this one out. There is no earthing at all. 13 ampere socket is there. I mean 13 ampere current is flowing through this. okay, through this fuse, and this electric iron is shortened. Why? Check this one out. There is a fault. It is broken, and it is, this heater is touching the surface. So when it touches the metal surface, this is dangerous. It will become live. Now this is live. Are you getting my point? Is Zainab in the class?
E- no, sir. It's just you and me.
Oh my god. तो तुम मुझे बताओ तो सही ना.
मुझे पता ही नहीं था, sir.
Okay, no problem at all. Okay, इस पे देख लेते हैं. What happens? Check this one out. If this
Your
heater,
screen
because
isn't sharing anymore, sir.
okay, that is good, because I was showing you a horrible picture of this
Oh,
guy. ये देखो. नजर आ रहा है
yeah, बिचारा.
बेचारा. So actually problem क्या हुआ? Electric iron casing is now getting live. ठीक है, because current is, voltage are available on the casing as well. So when this guy touches this, तो क्या होगा? The current will flow through his or her body to the ground, and there will be an electric shock on this, on the body of this person. अब same wire है, ठीक है, nothing is happening because what happened? You have properly earthed the wire. ये देखो, body के साथ आपने wire को touch किया, and that is connected with this. So when it is connected with this, there are three pins. One is your black, one is your red, and one is your green wire. So this is earthing wire, and this earthing wire क्या करती है कि अब देखो बहुत इंटरेस्टिंग बात है. Through live wire, the voltages are flowing through the heater to the body. Now there is nothing in the neutral wire. All the current is flowing through body to the green wire, and because green wire is the short circuited wire, then what will happen? There will be a huge current flowing through that, and fuse will be broken. When fuse will melt, now it is safe for everybody. इसलिए हमारे पास क्या होता है, आपने देखा होगा कहीं शॉर्ट सर्किट हो जाता है, तो बेसिकली वी हैव सर्किट ब्रेकर स्विच ऑफ. ऐसे ही होता है ना, सर्किट ब्रेकर आपका क्या होता है, स्विच ऑफ हो जाता है, उसको दोबारा जाके कनेक्ट करना पड़ता है. तो इंस्टेड ऑफ अर्थिंग वी हैव अ डबल इंसुलेशन एज वेल. ठीक है, ताकि इफ दिस वायर इज डैमेज, दिस ओवर यानी द इन outer layer will not let it to touch to the body of the appliance, so that will make as a safe use of electricity. Then there is one more thing. Yes, 3-pin plug, that is in our syllabus. In 3-pin plug, just check it out. In that plug there are 3 different positions of the wires. देखो ये plug लगता कहाँ पे है? First you have to notice that the plug will be plugged in over here. ऐसे ही है ना? So this is the neutral point. So here there must be neutral wire, there must be earthing wire, and there will be live wire. Now I will go back to the point. ये आपका है socket, it is not plug. ठीक है, is it clear to you?
yes, sir.
अब देखो, go back to this. It means when you will put the plug in the socket, this point was fixed on the neutral, so it must be neutral. This point was fixed on the earthing point, so it would be earthing. So this was the point which was basically at the live position, so it must be fixed in the live. But no, the wire is connected here, and through the fuse it is connected to this. तो अब आपने क्या कर दिया हुआ है, you have provided another safety here which is fuse. तो होता ही है कि when you make a connection in the wire, आपका voltage यहाँ से in हो रहा है, voltage यहाँ से in हो रहा है. Are you getting my point?
Yes,
मैं
sir.
समझाता हूँ आपको. Voltages are getting in from here, they will move through this, through this, through this, and they will go to the appliance. ठीक है,
ठीक है सर।
तो अप्लायंस क्या करेगा, अप्लायंस वुड हैव अ न्यूट्रल वायर एज वेल, यानी अप्लायंस के पास वापसी पे दिस इज द न्यूट्रल वायर and that will be connected over here. So what is the function of then earthing? Earthing wire is basically a wire which is yellow and green, ये जो आपका color है, that wire is not touched by these wires physically, but यहाँ पे थोड़ा सा touch हो रहा था इसलिए that is connected to the body. तो अगर आपके पास कोई appliance heat up हो जाता है या short circuit हो जाता है, तो basically these wires will make this much, यानी let's say this is the motor, ठीक है, these are 2 points ना, एक साइड पे आपका मोटर का करंट इन हो रहा है एंड फ्रॉम द अदर साइड करंट विल बी आउट, बट दिस इज टच विद द बॉडी केसिंग ऑफ द मोटर. So if there would be a short circuit or there is a sort of issue, then what will happen, the current will flow through the earthing and then it would be safe. ठीक है, so just make all these points clear to you. Yeah, these are 2 pin wires, यानी lightning में आपने क्या करना है, this is just a practice that where we have to place the fuse. The fuse is placed in the live wire. This must not be placed in the neutral wire because when you yeah, switch का भी बात कर रहे हैं हम लोग. So before applying the bulb or before applying the appliance, क्या करते हो आप, स्विच ओपन कर देते हो ना, ऐसे ही होता है ना, कहीं अब्बू जी बल्ब चेंज कर रहे हो तो क्या करते हैं, पहले बटन ऑफ करते हैं ना पीछे से, बच्चे ऐसे ही है. ठीक है, so if the switch is at the live neutral wire, then you are continuously under the threat because voltages are available and you are working on the live wire. इसलिए ये काम नहीं करना. ये बाबा जी को करंट लग भी गया, देख लो. So this is basically your appliances, yani practical electricity. I hope that this all would be clear to you. There would be no issue at all. And with the help of this topic, now your current electricity is entirely completed without any discrepancy. Okay जी, अरीबा.
Yes, sir.
और अब मुझे ये बताइए कि यस, दैट ऑल इज डन, एवरीथिंग इज डन. हमारी सेहत की क्या पोजीशन है अभी? आई एम सॉरी, मैंने काफी लेट मुझे पता चला कि यू आर